Hello everyone, this is Gaurav Singh along with Vara Prasad, Emmanuel and Medapati Bhagyasri. We are intern at EMERTXE Technology. During internship we have built a home automation project based on IoT. I am going to give a presentation on our project which is IoT based home automation. We are divided our whole project into four sections. I am going to take section 1 and remaining section are taken by my colleagues. Topic learned during internship: C programming. In C programming we have learned variable, operator, keywords, concept of arrays, pointer, function and some basics of C++. General aspect of C. C was originally developed in 1970s by Dennis Ritchie at Bell Telephone Laboratories. C is high-level general-purpose structured programming language. Instruction of C consist of terms that are very close to same to algebraic expression. C contains certain additional features that allows it to be used at low level, acting as bridge between machine language and high level language. Variables. A variables is nothing but a name given to a space. Variables are used to storage of data type. Each variable in C has a specific type which determines the size and layout of variables memory. There are different types of variables in C like char, int, float, doubles and many others. The size of char variables is 1 byte, the size of int variables is 2 byte, the size of float variables is 4 byte and the size of double is 8 bytes. Operators. An operator is a symbol which operates on a value or variables. For example, plus is an operator to perform addition. Similarly, minus is an operator to perform subtraction. There are different types of operators. Some are listed below: plus, minus, asterisk, forward slash, modulo. Modulo gives the remainder when two numbers get divided. In C, there is some relational operator. A relational operator checks the relationship between two operands. If the relation is true, it returns 1. If the relation is false, it returns value 0. Relation operators are used in decision making and loop. Some of relation operator are equal, greater than, less than, not equal to, greater than equal to, and less than equal to. Keywords. Keywords are nothing but system defined identifiers. Keywords are reserved words of the language. They have a specific meaning in the language and cannot be used by a programmer as variable or constant name. There are 32 keywords in C programming like break, else, long, switch, case, enum, register, typedef and many others. Array. What is array in C? An array is C is a fixed size collection of similar data items stored in a contiguous memory location. It can be used to store the collection of primitive data types such as integer, char, float, and also derived and user-defined data types such as pointer, structure. Syntax. The declaration of array is int arr 5, where in square bracket it represents the size of array running from 0 to 4, where initial index is 0. Integer is a type of value stored in array. Pointer. A pointer is a derived data type in C that can store the address of other variables. With the help of pointer, we can manipulate the data stored in the memory location. Syntax. Data type asterisk symbol pointers name. The most important things in C programming is function. Function are set of statements that takes input, perform some operation and produce result. The operation the operation of a function occurs only when it is called. The use of function is to reduce the size of program. Syntax: int, sum, int a, int b. Int is a return type, sum is a function name, int a and int b are the parameter. C++. C++ is an advanced version of C. There are many differences between C and C++ which are listed below. C language designed by Dennis Ritchie in 1972, whereas C++ language designed by Bjarne Stropus in 1979. C does not have concept of object-oriented program, but C++ have concept of object-oriented program. C is a low-level language. C++ is a middle-level language. C is an old version. C++ indicate that it is a updated version of C language. In C language, data cannot be hidden. In C++, data can be hidden. It has 32 keywords, but in C++ there are 52 keywords. For the input, we use scanf function in C, whereas we use cin for the input in C++. Printf is used for output in C. Cout is used for output in C++. Use the file extension of C.C and .cpp for C++. C is a function driven, but C is object driven. So this is a part 1 taken by Gaurav Singh, and the next part is taken by my colleagues.
Hi guys, my name is Varaprasad and my project is IoT based home automation, and this is a group presentation. So our group members are Gaurav Singh, Ashok Emmanuel, Madapati Bhagyasri and me Varaprasad. So let's start the presentation, which is part 2. So part 2 is about Arduino. So the introduction to Arduino. What is Arduino? Arduino is a board which we are using in our daily projects for students. So it is a microcontroller based board. We are using Arduino Uno in our project. So what is Arduino? So Arduino is widely using by students nowadays, and it is also useful to the lecturers or teachers to teach the students how to create electronics projects fast and easier way. It is also helpful in learning embedded C and embedded systems also. It gives a very good and understanding about embedded projects, and it is a very useful tool to learn embedded systems. To the best of my knowledge, I am saying this. Arduino is a microcontroller. So what is a microcontroller? A microcontroller is a microprocessor with memory and some other peripherals with connected to it, and having random access memory also. So this microcontroller is used for a particular task in our daily systems like ovens, washing machines, ACs, refrigerators, etc. So microprocessor we are using in our computers, that is laptops, computers, mobile phones. So multiple programs can be run by processed by microprocessors. Microcontrollers is only designed for a specific task. So different types of Arduino is here in this showing. So Arduino kit, which is showing with a breadboard. So Arduino lily pad is it look like a round disc shape device, while the processor is connected with the along with the RAM, peripherals, etc. And these leaves are showing the pins of this processor or the board. So another type is Arduino Uno and Arduino Mega. So this DIY Arduino board is built by do it yourself. So it's a homemade Arduino board. So in this project we are using Arduino Uno board. So what is Arduino Uno? What does it have? 14 digital and input output pins. 6 of them are PWM outputs, 6 analog inputs, an USB connection, a power jack, and a reset button with a LED on board, and the serial peripherals, that is SCL, SDA. What is SCL? SCL is a serial clock. This serial clock is used. The serial clock is used to transmit or receive the data according to this clock. So serial data pins carry the data information in bits. In short, about Arduino, it contains the everything we needed to support microcontroller. So we can simply connect it with the Arduino board to a computer with a USB cable, and we can power it through USB, or we can separately power it with a power adapter, that is AC to AC adapter, or a battery. We can connect this 12 volts power supply. So in this figure it is showing Arduino Uno board. So it is having a power input port and USB to computer, then the reset button, and this SCL and SCA pins, that is serial peripheral interface, and 14 digital IO pins along with 6 analog input pins. 6 of the digital pins are PWM, and we can manually power it by connecting to the jumper cables. We can power the microcontroller separately if the power input fails. Also we can power this board using a USB cable from the computer. So how to code in Arduino? So it is very easy to code in Arduino by using this Arduino IDE software, which is available in the internet, as it is a free software available to everyone. So we can simply download it and install in the computer. So once installed, the screenshot is showing after installation. You can directly open it. So after opening, the startup shows like this screenshot. Okay. So these error and status messages, this console is used to show errors and status messages when this program is compiled and executed. If errors are present, errors are shown in the console. So after installation, we have to do the project on Arduino board by connecting it to the computer using USB. So before connecting, we have to program our Arduino board so here we are having a menu in that Arduino IDE. In that menu section, the toolbar is there. So in toolbars, we have the board section. When it is clicked, the different types of boards are shown. So we are using Arduino Uno, right? So we are selecting that Arduino Uno. So now we can start the programming in this IDE. and upload it to the Arduino board. So this Arduino is programmed with Arduino software. All these peripherals are connected with computers are using a serial port. So this serial port is connected in the system is COM3, so it is available, we can use that. So we can check the port for Arduino Uno in a device manager, which is available in our PC. So input versus output. Here inputs are given through sensors and switches, push button switches, like switches. Okay, so these input transducers transforms the input into signal. All these processes are done by the Arduino board. So we can upload the code to Arduino, then only it works. After taking the inputs and processed by the Arduino, the output is given to output transducers as motors, speakers, etc. So 6 major concepts in Arduino, that is digital write, analog write, digital read, if statements and boolean statements, analog read, and serial communication. So digital write is a digital pin configuration. We can use 14 digital pins, 6 of them are PWM. So digital write is used for digital outputs. Analog write is used for analog output sensors to drive them. Digital read is used for in taking digital input, which is actually digital in nature. So if statements are used for conditional statements. So analog read is used for analog inputs from the analog sensors. This serial communication is used for serial peripheral interfaces. So analog versus digital. So microcontrollers are digital devices as it operates on DC voltages. So what are digital? Digital means ones and zeros, also called discrete. So analog signals are anything that can be of full range values. For example, we take a sine wave as a analog signal. Here 0 means logic 0, 5 volts means logic 1. So it's the digital signal, and here we are showing a triangle signal, that is 0 to 5 volts of full range. So it is an analog signal. So analogs, there are sensors in digital and both analog also. So analog sensors are mic, photoresistor, potentiometer, temperature sensor, flux sensor, accelerometer. So mic is a analog sensor used to detect the voice and process them. So mic is also called as a transducer, which transduces sound analog into digital information. The photoresistor is used to measure the intensity of light. Temperature sensor is used to measure the temperature. Accelerometer is used to sense the acceleration and tilt. So digital sensors. Digital sensors are more straightforward than analog. No matter what the sensor, there are only two settings, on and off, as it is a digital. So for example, a switch and a push button, these are used as digital sensors, etc. So serial communication. In serial communication, the amount of data is transferred in the form of bits, ones and zeros. So when these bits are used to serial communication through a single cable, while uh, while we uploading the code to Arduino board, the RX blinks when receiving data and TX blinks in the Arduino while transmitting data. Both these LEDs are provided in Arduino board. So okay, let's start the coding. So here we are using just a sample presentation. It is a demo. We use the LED blink as our program in Arduino code. Here we are using digital write, one of the 6 major concepts like digital write, digital read, analog write, so etc., and serial communication. So Arduino IDE is a compiler and a code writer. So we are using this code to blink on and off the LED by using a digital write. So here the demo. So the same code I'm showing this Arduino simulation using online simulator. So this is the board. See, the LED is blinking. The same code is written here. First we initialized the pin 13, which is connected through a resistor to LED. The digital write at 13 high indicates glowing LED. The digital write 13 low indicates LED low, that is off. Delay here we provided is 1000 milliseconds, that is second. See here we also quoted it is a comment line. So this is the simple presentation about Arduino. Okay, so guys, thank you.
Hi guys, this is Bhagyashree Madapati along with Asago Emmanuel and Varprasad and Gaurav Singh. This presentation about what is IoT and the project is IoT based home automation. Here we can see the contents of IoT. First one is topics learned during internship, and the second is what is IoT, and the third one is IoT architecture and what is embedded system, project requirements and requirements, screenshots, conclusion, and finally implementation. And first one is a topic learned during internship. Coming to the topic learned during internship, in C programming, keywords are basic data types: int, character, float, double, void operators, conditional constructs and looping concepts, arrays, pointers, functions, built in and user defined functions, storage classes, preprocessor, directive, and header files. And the topics learned during internship is C++ programming, um, introduction to IoT, definition of IoT and IoT architecture, introduction to embedded systems, definition and types of embedded system, components of embedded system, peripherals, LED, Arduino UNO, CLCD, 14 pins, description of CLCD, and ADC, use of ADC in Arduino. And the next one is what is IoT. Here we can see what is IoT, the Internet of Things, which is shortly called as IoT, and is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools. With more than 7 billion connected IoT devices today, experts are expecting this number of grow to 10 billion by 2020 and 22 billion by 2025 by means of low cost computing, the cloud, big data, analytic, and mobile technologies. Physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital system can record, monitor, and adjust each interaction between connected things. This physical world meets the digital world and they cooperate. Here we can see the architecture of IoT. And what is embedded system? Here we can see what is embedded system. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. It has three parts: software, firmware, and hardware. Unlike computers, embedded system perform few specific limited tasks. Embedded devices have peripherals such as the serial communication interface, which is shortly called as SCI, and synchronous serial communication interface, universal serial bus USB, multimedia cards, SD cards, and compact flash, etc. Here we can see the embedded system. Um, the CPU, which is a software and a diagnostic port, D by A conversion and A by D conversion, and human port, auxiliary system, actuators and memory, and digital hardware and sensors. Here we can see the project requirements. These are the project requirements to do the project of IoT based home automation. Control garden light in basis of sunlight intensity, lesser than sunlight, brighter than garden lights. Temperature system control, which heater the cooler on or off remotely, which switch heater off automatically if temperature indoors exceeds 35 degrees. And are the main requirements for the project. Hardware requirements are Arduino UNO and LCD HT44780 and LDR sensor and temperature sensor. Here are the hardware requirements, and coming to the software requirements are Arduino IDE 2 code, um, PISC MLab for simulation, Blink IoT app, cloud server. These are the main requirements for um, for the project. Arduino UNO. Arduino UNO is based on um, Mega 32 8P microcontrollers. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input, output, and shields and other circuits. The Arduino UNO includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and in ICSP, which is called in circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. Here we can see, uh, coming to the next part, temperature sensor. Temperature sensor is an electric device that measures the temperature of its environment and converts the input data into electronic data to record or monitor or signal temperature change. Here we can see the temperature sensor, which 4 to 20 volts, and out ground and LM35, which is having three strips, 1, 2, 3 located in the picture. Um, Coming to the LCD HT44780. LCD HT44780 is a dot matrix liquid crystal display controller and driver LSI displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of 4 or 8-bit microprocessor. And next one is LDR sensor. An LDR is a component that has a variable resistance that changes with a light intensity that follows upon it. This allows them to be used in light sensing circuit. The resistance of a photo resistor decreases with increasing instant life intensity. In other words, it exhibit. And here are the some few steps involved in this. Step one is when we load the hex file, and the next one is and the next one is LDR is high, so LED is on. LDR is low, LED is off. When LDR is in high, automatically the LED will be on. LDR is in low position, the LED will be off automatically. Here you can see the cooler is on and cooler is off. Here we can see heater is on and heater is off. Picture notification of heater temperature. In blink IoT, we can see the heater will be in off position, cooler will be in off position, and the temperature we can see here 33.72 out of 100. In next, heater will automatically turn off when the temperature rises above 35. Here we can see the temperature will be 35.19 out of 100. So the automatically eh, the heater will be in off position. Coming to the conclusion of the project of home based IoT based home automation, which is using Blink IoT application and Pix MLab simulator simulated home automation where LED temperature system resembles light heater and cooler in real time. CLCD acts like a dashboard used for displaying the events widgets from Blink IoT app like button widgets are used to control heater, cooler, and LEDs. Gauge widgets to display the temperature. Thank you for giving this opportunity. Thank you so much.
Hello, this is the final part of our presentation. And in this part, we show the implementation and the demo. So this is a block diagram of the system. As you can see, the diagram is set up to satisfy the requirements that have been defined. You can see the temperature system, Ethernet shield, Blink cloud, Arduino Uno, and serial tank. And you can see how they are interfaced with the Arduino Uno. So this is what you are going to implement in software now. So this serial tank is interfaced using serial communication, while Blink is interfaced using Ethernet shield. Like it connects, it talks to the Arduino through the Ethernet shield. So this is like the components used in implementing the various blocks. This is garden light control. As you can see the LED and the light dependent resistor. So this light dependent resistor controls the brightness of this LED by by varying this, you can control the brightness of this LED. Then the next block is the temperature control block. So as you can see, this block consists of a temperature system, then this Ethernet shield, and then this um CLCD, and then the IC that allows it to communicate through SPI. Sorry, I2C. So this is how we set up the temperature control system using the Pixim lab. Then this is the serial tank. So this serial tank is interfaced using serial communication to the Arduino, and this is just a diagram of how we are going to implement it. Then the next thing here is the setup function. Like I added this because they are like the major functions in the major blocks in the program. So as you can see here, you have your this is just the setup. This setup is where we call functions that should run once to set things up before running the program continuously. This here we initialize LDR. This is just initializing the LCD and then turns on the backlight and so on. Then here print the temperature. Temperature equals to and volume equals to. In the loop, we are going to vary the values of temperature and volume based on what is returned by the sensors that are being interfaced. Then this blink dot begin takes this argument to connect us to the blink cloud. Depending on this varies depending on your authentication ID. Then here we initialize the temperature system. The full block is given in the code, but these are just like how the big blocks fit together to form the whole system. Then here you have your serial tank. Here we are initializing the serial tank, and this we are using this to call this function every 500 milliseconds or half second. So actually, this last line is not among it. It's added as a debug line, but it's not among the program, so you can ignore this. Then here in the loop function, you can see we are this blink dot run continuously connects to the blink cloud and then transmits the necessary information and so on. Then this timer dot run sets up the timer to execute this line every 500 milliseconds. Then this controls the brightness continuously according to the variation in the resistance of the LDR. Then we read the temperature, we display it, we read volume, we display it, and then this handle temperature and handle tank deals with the thresholds, like when it is when temperature is more than 35, there is a condition. Then for this, when volume of tank is less than 2000 liters, there is also a condition set there based on the requirements. So this handles those requirements. Then this is the complete dashboard as we designed it. So you can see here everything have been put together and working as it should. Then this is the serial tank. You can see it filling. So we've connected everything and set it up. So before ending, we want to I want to show the output, how everything is working together. So that's the next step. So here is the setup. You can see that it's already on and working. But what I want to do now is I want to reset it. So reset. Now it's connected, and so as you can see now it's connected. So now we can test it out. Yeah, it works properly. So coming to Blink Cloud now. You can see here the device is online. So when I press this is cooler pin. See, cooler pin turns on the cooler. Then heater pin increases the temperature just as expected. Then we can turn it off. Then as for the temperature pin, for some reason it's not working properly. But I've tried to debug it many times, but still it's not giving the expected output. That's the only widget that is not working as it's supposed to be. Then here you can see here, if the heater is, let's see the message is being displayed. Message is displayed as, because the that requirement of it's being more than 2000 have been exceeded. So you can see that the message is being printed on the terminal. Then the tab 2 shows the inlet valve and the outlet valve. So this is the serial tank. And observe the serial tank. So This is the inlet valve. Okay, before then I have to show the screen. So this is the inlet valve. See, turning it on, start filling, and I can also turn it off. And the gauge is working properly. Unlike the temperature gauge, this gauge is working as it should be. So I can turn it off now. Then can empty the tank, can fill the tank. So this is all about the output. Ev- All the peripherals are working as they are supposed to be, but the temperature gauge is not working properly. So that's the only widget that is not functional, but other ones works as they are supposed to. So fill tank, empty tank, and the gauge is responding here. So this is it about our presentation and our project. This is all we have implemented. So before ending, I want to thank the organizers for giving us an opportunity to learn and to teach us industrial skills, relevant skills. So very thankful, and this is the end of our project. Thank you.